The weekend is upon us. I can't wait. I can't wait. So, what do we got here? Announcements first. Check your Atlas grades. The test scores are in there. So you can take a look at those and see whether you want to do test corrections. Test corrections are due Sunday night for exam number 2. So head on up there, over there, get those done if you would like to. Pretty soon I will release the actual exam scores, the actual questions to you. And if you want, you can start working on test corrections for exam 3, if you so desire. But I need to wait a little bit longer because there's still a handful of people that need to take the test. And so I'd like to have them take the test before I let the answers out into the wild. So, beginning of next week, I'll probably release the answers and the questions on forums. Until then, though, the curved score is in Atlas for you. All right, let's see here. Picture of the day first, right? Yeah, let's do picture. Good Friday, lighthearted one here for you. I don't know if you saw this or not, but here's someone having a bad day. Happened in the Netherlands. Not every day you get to say that a whale tail saved a train car from falling 30 feet, but here it happened. Apparently, a little bit of user error or something with the train operator. I think it was supposed to be parking it, but fell asleep or something else and crashed through the barrier. And of course, many trains are elevated in big cities. All right, so that's why it's so high. It's not running along the street level. But saved by the whale tail. I like how the firefighter's just like, what do you want me to do about it? I mean, take a picture? Have you tried putting it in reverse? Maybe you can just back it back on. I mean, like it never happened. How much you want to bet the conductor, who is, by the way, probably sitting right here, tried that? Oh, crap. No one will know, right? Reverse. Not the first time either, actually. We have a history of this happening. You might think, humans, why are you elevating these really big, heavy machines that go fast? Stop it. But, yeah, it's happened before. Engineers say, though, as they're looking at this, they don't think the whale's tail is actually holding up the train. Sculptures like this are usually made of plastic, and they're hollow. There's no way that actually be supporting a train that probably weighs like 30 tons. Hollow plastic ain't gonna do that. Yeah, I had to ruin your Friday somehow. It's what I do. It's what I do. So it's probably the coupler to the other train that's holding it a little bit, but hard to say. Hard to say. I definitely wouldn't stand under it, though. It looks like the firefighters are, kind of, doesn't it? But I'm pretty sure they're not. Alrighty, ladies and gentlemen. If you haven't clicked on the Nearpod link, please do that. It's in the general channel right next to the join for the meeting. Open up the Nearpod. We're going to be bouncing back and forth, like kind of usual, between the notes and the Nearpod. So start logging into there. I think our first thing is actually in the Nearpod this morning. So first things, I think we're heading towards there because, yeah, we got to look at simulations a little bit. The first thing we're doing today is looking at simulations, but instead of a simulation using your calculator and a random number generator, we're going old school. All right, back in the day, before random number generators and the internet, you had to get random numbers somehow. And there are actual books of random numbers. Like page after page is just line after line of numbers that are randomly generated somehow. Because random is actually kind of hard to achieve, believe it or not. I think I gave you guys the story of the stats professor on day 1 told half his class to fake the heads or tails flips, and he could tell that none of them were actually random. Humans cannot just randomly make random numbers. Actually kind of hard to do. So there are books of random numbers, and part of the standards in this class is for you to actually know how to use them, how to use a random number table to do a simulation. So we're going to do an example of that before we move on to Venn diagrams. A lot of probability can be done with Venn diagrams. That's why I got you the pointless and useful and funny comic that sucks, period, I guess. But we will look at Venn diagrams towards the end. But first, we got to make sure we can do these simulations with a random number table. So the Nearpod is self-paced this time, all right? So you can click through it, but please stay with me. Don't go ahead, because I think you might get lost and it won't be, you'll miss some things. So stick with me as we go through the Nearpod. I'll tell you when to go to the next slide, etc. So you should be in there on slide 1. Slide 1 is a review from last time just to get us going. We did do this slide last time, but our first example is going to be the last example we did last time, which was there is a lottery to get the 2 golden parking spots on campus, and 2 students from the AP Stats class got it. Everybody cries foul. How likely is it that 2 students from the same AP Stats class get the lottery winning tickets if there were 95 students that were allowed to participate? All right, so hopefully that sounds familiar. You remember that from last time. So do that first slide, fill in the blanks so you remind yourself the simulation we're doing. And then we are going to change that simulation so we can do it not with a calculator, but with a random number table. Okay? So I'll give you a minute or two to fill that out. Oh, and someone was telling me if you get some of the we're going to do another matching one as well. If you get the matching wrong, if you want to redo it, you can go forward a slide, then backwards a slide, and then it resets, and you can do it again. That's what I'm told, by the way. I've never done it myself. All right, looks like most of us have got that. So in essence, we are picking a number from 1 to 95. If it's between 1 and 28, or including 28, it's an AP Stat student. If it's between 29 and 95, it's a regular student. We randomly generate pairs of numbers and see if we ever get some from 1 to 28. If they're both 1 to 28, then that is 2 stats kids getting the golden tickets. And that's really easy with a calculator. It can generate those numbers for you. How do we do that without a calculator? So the next one, if you click to the next slide, the PDFs are in the Nearpod. I don't know how well that works because you click on it and they're the wrong direction. And so if you see something kind of like this, you have to first flip the drawing by, there's a rotate button at the top. You can rotate it, rotate it, rotate it. It's a little big. You might have to zoom out a little bit. So the book has the answer there for how you would do that simulation, but with a random table of numbers. I'm going to go through that on my screen. I put it in the OneNote here. Yeah, come on. There we go. And so I'm going to go through the book's answer and show you the differences in the description for that simulation. A few things you have to add if you're doing it with a random number table instead of a calculator, sadly. It's a little bit more complicated, but not that different. So take a look at this. The first thing they do in that PDF, label the students in the AP Stats class from 01 to 28. Now that is pretty much the same. All right, there's one small difference there compared to with a calculator. All right, so the first difference, when you label, all right, outcomes, you need to be careful about digits. Okay, so if you are using two-digit numbers, like the number 28 or the number 29, all the numbers have to be 2 digits. Okay, so the key here is the number 1 is not just the number 1. It's the number 01. All right, if we're going to use 2 digits, you always have to use 2 digits. So the 01 has to stay 01. So be careful about digits for your outcome. That's the first thing you have to be doing when you're describing a simulation with random number tables instead of a calculator. All right, and label the remaining students from 29 to 95. All right, that's pretty much the same. Here's a difference. Numbers from 96 to 00 will be skipped. You never have to say anything like that with a calculator because you can tell it exactly what numbers to draw from. But you can't tell a book what numbers to draw from. So if you aren't using all the in this case, all the 2-digit numbers, you do have to say which numbers are being skipped. Which numbers need to be skipped. So in this case, because we're only going to 95, we don't need 96, 97, 98, 99, or 00, which kind of represents 100 in some ways. We don't need those. And so we have to say, if those come up in our table, we skip them. Okay. Let's see what happens next in this description. Ooh, move left to right. Yeah, for some reason we have to say, every description does that you move left to right. I feel like we know how to read, but maybe not. So move left to right is another difference. All right. Look at pairs of digits until we come across 2 different labels. All right, so I think this part right here. Look at pairs of digits. So you have to say how big of a number are you looking at. All right, be specific. What are these steps for? If you are doing a, if you are describing a simulation for a random number table instead of a random number generator. All right, so yes, it's easiest if you use a calculator, right? Give me a random number from here to here, and you're good to go. But I'd like you, and the College Board also would like you to be able to do this old school. where you don't have a calculator that will give you any random number set that you want, or you have to use, and you get a little preview right here. Here is a random number table right here that we are going to use to generate our random numbers. And so we have to be able to describe how to use that random table. Okay? Hopefully you can see it's much easier using a calculator, right? You can just say, give me a number from 1 to 95 and be done with it. You cannot tell a book, give me a number from 1 to 95. And so this is telling you how you would use that book to give you a number from 1 to 95. So I was saying be specific about the number of digits you look at. So here we're looking at 2-digit numbers. So we are looking at pairs of digits. Until we come across 2 different labels, that's pretty much the same as always, from 01 to 95. The 2 students with these labels win the prime parking passes. That's the same as our other descriptions. Record whether or not both winners come from the AP Stats class. That's the same. Perform many simulated lotteries. That's the same. See what % of the time both winners come from this stats class. Again, that's the same. So these 4 things here, it looks like, those are the only differences between describing a simulation for a random number generator in your calculator versus a random table from a book or from a list that is given to you. And yes, our book in the back, if you flip in the back, you will see just these pages. It's like 2 or 3 pages of just numbers, a list of numbers. And they're randomly made numbers that you can use for simulations like this. All right, so now you actually go to that table, you look at this long list of numbers, and now we are actually going to do this simulation. So instead of just hitting enter on your calculator to give you a number from 1 to 95, we look at these numbers. So first, our first 2-digit number is 70. All right, that is a regular student winning the lottery. All right, but remember we pick 2 students. All right, 2 students can win. So that's our first student. What is our second? Ooh, the next number is also a 70. Well, we can't have the same person win twice, right? We need unique numbers. So that's why they crossed that one out. Then the next number is 84. And the space between numbers doesn't mean anything. It's just to be easy on the eyes. All right, if these numbers were all squished together, it'd be kind of hard to read. So they space them out in groups of 5 or 4 or 3 or 6. I'm guessing 5 is the standard, but the grouping doesn't mean anything. It's just to be easy on the eyes. So our first trial, we got a 70 and an 84. The first random number is a 70. The second is an 84. Did both stats people win? No. All right, record whether or not both stats people win. So our next 2 numbers are 10. Ooh, 98. 98's too big, right? We don't get to use the 98 because we said skip 96 to 99. So I have to skip that one, the 98. And the next one is a 55. So a 10 and a 55 are my next 2 random numbers. They are not both from the stats class. All right, after the 55 is the 18. And then I think that's a 19, I'm guessing. Looks like a G, but 18 and 19 are my next 2. Oh, and that is a yes. Both of those students are from the AP Stats class. So instead of having a calculator give you these numbers, we're getting them from the random table, and we have to be able to describe how to use that random table. All right, holler at me again if I'm not making any sense at all. Hopefully I covered a lot of the bases there. We're going to do one more example of this so you can kind of get the hang of describing a simulation using a random number table. All right? So here's that scenario. In the game of Scrabble, each player begins by randomly selecting 7 tiles from a bag containing 100 tiles. All right, if you haven't played Scrabble before, Scrabble's where you make words. Oh, that's a new thing on Facebook and stuff, isn't it? All right, it had a resurgence. Scrabble Online. There are 42 vowels, 56 consonants, and 2 blank tiles in the bag. All right? That makes 100, right? That does make 100. Kate chooses her 7 tiles and is surprised to discover that all of them are vowels. We want to perform a simulation to determine the probability that a player will randomly select 7 vowels. Okay, what's the probability of randomly getting 7 vowels out of that? So, first we got to describe the simulation that we're going to do, and then we're actually going to do it. Now, I gave you another fill in the blank on Nearpod to do that simulation, okay? So head on over to Nearpod and see if you can fill in the numbers, fill in all the blanks for that description for how to do that, all right? Give you a few minutes, and then once you have the description filled in, head on over to the next slide to actually do that simulation by circling the numbers. The Nearpod lets you do all of that. It's kind of cool. This one's definitely a bit harder. If you want a little help getting started, so label the vowel tiles from blank to blank. And I look at my options. I'm guessing at first you might want 1 to 42, but Bolt was obnoxious. There's no 1. So the one we're going to start with is the 0, 0. So if that's our starting point, from 0, 0 to where will give us 42 numbers. A little tricky there. From 0, 0 to 41 will give you 42 numbers. 0, 0 to 41 will give you 42 numbers. So again, if you are done doing the matching, head on over to the next slide where you can actually start performing a few trials of this simulation using those random numbers. See if you can start circling the picks and recording what they mean. All right, let's talk about that simulation. I got the answer key over here for us. All right. So why did I pick some of those numbers the way I picked them? I think that's the main weirdness about this one. All right. So here we need 100 numbers. Okay. And so usually when we're using a random number table, if we have something like this, 1 to 100, and we have to be careful about our digits, how many digits are we using? If I choose 1 to 100, this actually has to become 001 to 100. Because if 100 is a 3-digit number, then the 1 also has to be a 3-digit number. And that's a little wasteful. If you're looking at 3-digit numbers over and over again, that will use up your number table faster. So how can I make 0 to 100 or 1 to 100 and only use 2 digits? Well, instead of starting at 1, start at 0, 0. And go 00 to 99. That is also 100 numbers, but now I'm only using 2 digits instead of 3. It's more efficient. Okay. Another option would have been 1 to 99 and then 00 as 100. That would have also been an option, actually. All that changes is the way you describe them. All right, so if you chose this one instead, that would change your descriptions in your simulation description. Okay, but both of these are plausible ways to do your numbers so that you only use 2 digits to get 100 numbers. So similarly, if you want to do 1 to 1,000, all right, you would not probably want to do 4 digits. 1, 2, 3. All right, because then you might end up with a number like 2, 641. 2,641. Well, you would have to skip that because you only want 1 to 1,000. Well, you're going to end up skipping a lot of numbers because you have to skip everything from 1,000 all the way up to 9,999. You're going to be skipping a lot of numbers if you want from 1 to 1,000. So instead, do 0, 0, 0 up to 999. Well, now you're not going to skip any numbers because you want 1 to 1,000. This is 1,000 numbers, and you aren't going to skip any. And it only takes 3 digits, which is more efficient. You'll be able to get more trials out of your numbers. Okay? All right, just a little clarification there of why some of the things were the way they were in that matching description. All right, time to perform a trial, ladies and gentlemen. So we need 7 randomly generated 2-digit numbers for each trial. All right, so when I do my first pick for my trial 1, first 2-digit number is 00. All right, I'm going to write down 00, which is a vowel. Right? And all right, now I pick again. I need 7 picks. Here's my second pick, 69. Ooh, that one is a consonant, right? And now I just go through and pick 2-digit numbers over and over again and then determine were they representing a consonant or a vowel. Every 7 picks, because they said we're choosing 7 tiles, is 1 trial. Every 7 picks, every 7 numbers gives us a full trial. And then we can record whether or not they're all vowels. Okay? So can you do that on the drawing screen there for me? I'm going to give you maybe 5 more minutes. Do that on the drawing screen and then submit it so I can see what you got. I don't think I get to see it until you submit it, sadly. But I would like you to do the rest of the trial. I think you can get 2 full trials out of this line of random numbers. So try that out. Shoot me a question if something isn't working. Otherwise, I will stay quiet over here and let you work. All right, hopefully you're getting there. I did 2 trials on mine here. So make sure you do report what you are supposed to report, okay? I think on ours we reported whether or not all 7 labels are vowels or not. All right, make sure you do report that. And so in both of these trials, the answer was, of course, no. This has got to be a tiny chance of happening, I'm guessing. So you could report no and no. We could have decided to report the number of vowels. All right, so I did that too. You could have reported the number of vowels, 3 out of 7, 4 out of 7, and then eventually maybe start making a dot plot of them. So how many vowels are there? 1, 2, 3, 4, 5, 6, 7. Do a dot plot, and the first one you'd put a dot on the 3, and the second one you put a dot on the 4. And then as you keep doing trials, you would add dots and see, do any of them ever come close to the elusive 7 vowels over here? I'm guessing probably not, but maybe if you did enough of them. Of course, it's very tedious, right? You can't do 100 trials this way. That would be just brutal. But back before calculators, that is what, and computers, that is what had to be done. And I think it is good for us to understand how that works. All right. So hopefully you've got an idea. Make sure you finish your drawing there. Hit submit on that. Hopefully that helps a bit. If not, come talk to me. I do want to spend some time on the next part. Any real quick questions about this process that I can answer right now? Alrighty. It comes up here and there. It is good to know how to do that. All right, our next topic. Man, why does it keep unselecting for me? Alrighty. Our next topic here with probability has to do with Venn diagrams. All right, so your video last time that you watched, hopefully before now, was talking about probability and two-way tables, how to find probability of events happening inside a two-way table. We did some of that in chapter 1 a while ago as well. We did a lot of probabilities and percentages of in a two-way table. So hopefully some of this is pretty familiar. But one thing that I don't think we have done yet is convert a table into a Venn diagram. Okay? So I'm hoping things like on your homework, you were finding things like, hey, what is the probability of having a pierced ear or being a male? All right, that was sort of things that your homework was on. What is the probability of having a pierced ear, which are these people, or being a male, which would be these people? And you would take that total and divide that by 178, right? So that would be 71 plus 19 plus 84 on the top, making sure you don't double count the 19. There's a lot in the video about the double counting of the 19. But that's how you could find that probability from a two-way table. But you can give that same information from a Venn diagram. All right, we can do that same information in a Venn diagram. And so I want you to see how they are in fact the same. So if you know how to do a probability with a two-way table, you can then also do that probability with a Venn diagram. So the first thing we have to do is label these circles. All right, what do we want these circles to represent? And you actually have a lot of choice here. Okay, there's lots of options for choosing what these circles will be. One of the circles is going to have something to do with a pierced ear, and one of the circles is going to have something to do with gender, one of each of our variables. And here you get to pick. So our first circle, we can pick, do we want it to represent yes, having a pierced ear, or do we want it to represent no, not having a pierced ear? You can choose. And so I'm going to choose pierced ear. So my first circle is going to be everybody with a pierced ear. All right, now my second circle. I go to my other variable. My second circle can either be all the males or it can be all of the females. You can pick what you want your next circle to be. Let's go with female. So everybody in this circle is going to be female. And so now what we got to do is figure out where all of these numbers in the two-way table go inside this Venn diagram. For me, it's easiest to start with the middle, the intersection. All right, it gets you going. So the intersection, of course, are the ones that are both female and have a pierced ear. So I have to go to my two-way table and find the number that goes with both female and pierced ear. So here is female and pierced ear is right there. So this number is going to be my people that are both female and have a pierced ear. So this number is going to be 84. All right, now let's see. Let's figure out what goes right here. All right, so these people in this side of the circle, they have a pierced ear, but they are not female. They don't belong in the female circle. So who are those people? Well, those people are the males that have a pierced ear right here. Okay, they don't belong in the female category, but they do belong in the pierced ear category. So that one will be 19. All right, now my other part of the bubble, who belongs in the female category, but not in the pierced ear category? Okay. All right, they're in the female category, but they're not in the pierced ear category. So that would be this over here, 4. And you can see there is one number left over, the 71. Where does that go? What the heck are these people right here? Well, these 71, they don't belong in the pierced ear circle. They don't belong in the female circle. So they're outside of both, out here. These people right here do not have pierced ears, and they are not females. They are males without a piercing. Okay? Now, that was not the only option to make this Venn diagram, of course, because remember at the beginning, I chose this circle to be pierced ears, and I chose this circle to be female. I could have chosen differently, and then the numbers would be in a different place. Okay? But again, if you want to get the same information, it is here. So if I want to find again the probability that we have a piercing or we are male, I can get the same information here. So probability that we have a piercing, well, those are the 19 and the 84 people. 19 plus 84. Or are male. So where are all the males here? Well, that are these people right here. Everybody outside of the female category are males. So the 71. Now, the 19 is also outside the female category. This is true, but we don't want to double count it because we already counted it once. And so I'm not going to count the 19 again just because these 19 are still males. Remember when I circled these, the 19 sort of gets double counted. So make sure you only count it once. Now, the Venn diagram, yes, is a bit harder because it does not give you totals. Sad face. No totals. You have to add up everything yourself. But that's not too hard to do, as long as you remember to add the total and find the correct total. All right, I want you to try to do this yourself here, okay? You are going to take a two-way table, this one, and you are going to put all of those numbers, well, all those numbers except the totals. The totals don't go in the Venn diagram. You're going to take those numbers and put them in your Venn diagram. The first thing you got to do is label your circles, okay? Now, there's many options here, so maybe I'll pick your first option. For the first, let's make our first circle here, plays an instrument. If you play an instrument, you belong in that circle. And we'll make the other circle plays a sport. Plays a sport. Okay, so remember, I choose one from the row. I chose this one. And I chose one from the column. I chose that one. And now I can start filling in this Venn diagram. This is the next slide if you haven't clicked on the Nearpod. So go over one slide in the Nearpod and you can start drawing that out. I put two of these on here because I am hoping that you can do it again and switch up the labels. Okay, so yes, right now we're doing these choices for our labels. But maybe you can do it one more time and choose maybe these as the labels. So you can see that there are multiple options here to choose from. All right, give you a few minutes, see if you can fill out that Venn diagram there for one circle being plays an instrument and the other circle being plays a team sport. See how that goes. All righty. All right, let me do this one real quick. A lot of you got that one, and I'm moving on to the second one. But just to check yourself here before you wreck yourself later. Plays an instrument and plays a sport. What is the intersection of those right there? It is the 8, right? Plays an instrument and plays a sport. There are 8 people. How many people are left that play an instrument? 3. All right, now there's 8 people that play a sport. How many are left that play a sport but not an instrument? 2. Now, take a look at your totals here. How many are in the plays instrument circle? If I do this big circle right here, how many people are in the plays instrument? There are 8, 9, 10, 11, and that's what it's supposed to be there, 11. How many people are in the plays a sport circle? So here's the plays a sport circle. How many people are in this circle? 8, 9, 10. Playing a sport will have a total of 10 there. So those totals work out. How many people don't belong in either of those categories? The people who are not in playing a sport and people who are not in playing an instrument. They don't do either of them. These people right here do not do the sport and they do not do the instrument, so they are on the outside. And if you add up all those numbers together, you will get 20. Few things you want to make sure there. Now, again, that wasn't the only way you could have done that. You could have done what? Plays a sport and does not play an instrument. Oh, I kind of switched those up. You can give me those donuts. Oh, sorry, I forgot about that joke. There are many ways to do this. What was another one? We could do does not play an instrument, does not play instrument, and we could do does not play a sport. You could do it that way as well. There's no real wrong way. I think there's 4 combinations that you could do to label your circles. There's 4 different combinations. They all give you the same info, just in slightly different ways. All right, ladies and gentlemen, that is basically 12:30. Let's call that a day, all right? Hope that went pretty well for you. I will see you all on Tuesday. Oh, man, remember we got our day off on Wednesday? Can't wait. Can't wait. Enjoy your weekend, everybody. Have a good one.
Thanks, Mr. Bolt. Have a good weekend.
You too, you too.
Thank you, Mr. Bolt. Bye.
Have a good weekend.